Here we are working with the factored form of the quadratic. So our goal today is that we can identify the x-intercepts, which are also known as the zeros of the parabola, as well as the direction and width of opening from the factored form of the equation. And then using these zeros from that equation, along with the equation itself, we can determine the vertex of the parabola. So I've just done a quick summary here of our information. We know that this value of a will always tell us the direction and width of opening, whether we have vertex form or the factored form. That a will tell us direction and width of opening. The factored form looks different from the vertex form because you have a bracket times a bracket. This value of r and this value of s will be the x-intercepts. So r comma 0 and s comma 0 will be your x-intercepts of that parabola. And because we have minus signs here, always think of just switching the sign to get the actual x-intercept. So it's the opposite sign to what you see on the page, because it's always x take away and then whatever the x-intercept is. All right, so for each of the following quadratics, we're going to determine the direction and width of opening, the x-intercepts, and then we're going to use those to get the coordinates of the vertex and then sketch the parabola. Now I need to zoom this in and see if this will work for me. Oh, good. I was worried that those blobs would not go with the things I actually highlighted, but it did. Here we are. All right, so if I look at this function right here, the value of a is right here, and there's nothing written right there, so our a is assumed to be a 1, because 1 times what we have there would just give us what we have. So 1 is positive. It's going to have a direction of concave up, and it's going to have the same width as y equals x squared. Okay, next we're going to look for those x-intercepts. They're the things that are being subtracted from the x. So x take away, and then we have positive 2, and x take away a positive 6. So our zeros are going to be 2, 0 and 6, 0. Zeros are x-intercepts. Okay, now eventually we're going to sketch this parabola, so I'm actually going to start putting those things on my grid, my axes. I'm going to put this over here. I'm going to set my x and my y. There's my x and my y. I'm going to plot a point at 2, 0 and at 6, 0. So those are my x-intercepts. And my parabola is opening up with the same width of y equals x squared. So I'm just going to sketch that parabola. I can label this value here as a 2 and this one as a 6. But what we don't have yet is the vertex, the coordinates of the vertex, which we're going to get now. And to get our coordinates of our vertex, we know that the axis of symmetry has to happen. That's supposed to be a dotted line, doesn't look very awesome, but whatever. That axis of symmetry has to happen halfway between those zeros. And again, to get that halfway point, we're going to find the midpoint of those zeros, and to get midpoint we add the two zeros together and divide by 2. So 2 plus 6 gives us 8. 8 divided by 2 is 4. So our x-coordinate of our vertex is going to be at 4, comma, and then we've got to figure out our y-coordinate of our vertex here. So our vertex is right down here. So it's a minimum value there. To get the y-coordinate of the vertex, we're going to take the equation that we have, and we're going to sub in 4, that value of the x-coordinate of the vertex, where we have the x's. So we're going to have a 4 take away 2, and then we have a 4 take away 6. So all I've done is taken my original equation, which was this, and replaced the x's with what I have found down here. So the x's became 4. All right, and now we just follow the order of operations here to actually calculate what our y value is going to be. 4 take away 2 is a 2. 4 take away 6 will be negative 2. 2 times negative 2 will be negative 4. So our vertex here, whoops, is at 4, negative 4. And now we have our sketch. So on your sketch, all you have to label are your x-coordinates for your zeros and the coordinate for the vertex. All right, looking at our next example here, the value in front of the brackets is the a. A is 2 here. It's positive again, so our parabola is going to be concave up, but it's going to be skinnier than y equals x squared. Now to get our zeros, we're going to look at what is being subtracted from x. So what I have here is x plus 5, which is the same as x take away negative 5. So one of our x-intercepts is at negative 5. Likewise with this one, x plus 7 could be written as x take away negative 7. So our x-intercepts are going to be at negative 5 and negative 7. All right, so we could sketch those on a grid, and then we can determine our x coordinate for our vertex by finding the midpoint. So to get the x coordinate of our vertex, we'll have negative 5. We're going to add negative 7. That's going to give us a negative 12. And then we're going to divide by 2 to get negative 6. Now that we know the x coordinate of the vertex, which makes sense, the x coordinate of the vertex is halfway between there, we're going to sub that value into the equation and solve for the y coordinate of the vertex. So y was equal to 2 bracket x plus 5 bracket x plus 7. I'm going to replace those x's with the minus 6. So minus 6 plus 5 and minus 6 plus 7 will give us 2 bracket negative 1 times positive 1, which gives us negative 2. So our vertex is down here at negative 6 comma negative 2. Okay, so that's how we come up with that information and how we can use that to get our sketch. All right, the last example here, determine the equation of the parabola with the x-intercepts here and here and passing through the specific point that I've given you. Now, it's just a work backwards kind of situation here. I'm going to start with that generic factored form of the equation with the a and then the x minus r and the x minus s. And then we're going to start by putting in what we know. We know the x-intercepts are positive 3 and negative 5. So if we sub those in, we're going to have, keep the a outside, we're going to have 3, sorry, wrong place. We're going to have x take away positive 3, and then we're going to have x take away negative 5. Okay, and up here, that's an s, it's not the number 5. All right, so looking at that, I'm going to change that take away negative to just be a plus 5. And if you can go directly to that without putting that step in, that's okay. I'm just trying to make things as clear as possible for you at home listening to this. All right, now remember when we had y equals mx plus b, and we knew the m, and we would sub that in, but we didn't have the b, but we had another point. This is the same kind of scenario here. We're trying to solve for the a this time, not the b. But we have another point. We have this point 1, negative 3. The 1 is the x, and the negative 3 is the y. So we're going to take that point, and we're going to sub that into this equation that we have right here. So this is going to go into here, and we're going to be able to solve that then for the letter A. Okay, so I've subbed the value of negative 3 where the y is and the 1 where the x is. Now we're going to tidy up those brackets, and we're going to change the 1 take away 3 to be equal to negative 2. So I'm just evaluating that, and 1 plus 5 is equal to 6. Now negative 2 times the 6 is going to give us negative 12. Negative 12 times the a would be negative 12a. And that's equal to negative 3. Now to get a by itself, we're going to divide both sides by negative 12. So let me do that in a different color. To get a by itself, I have to divide both sides by negative 12. Now I'm going to leave that in fraction form. It does work out to an okay decimal as well, but that's going to give me that a is equal to, a negative divided by a negative will be positive. A 3 goes into itself once, 3 goes into 12 4 times. So it's 1/4, or if you want to take that to a decimal, you can. So now we have our equation that for this particular parabola. So our equation is y equals 1/4, or 0.25, and then bracket x take away 3, and another set of brackets of x plus 5.